So, hello, and thank you for joining today's PLC2 webinar. My name is Anna Kassi, and I'm your host today. Welcome back. It's maybe better because today is part 2 of our webinar series about the free and open source PoC-Library. And in case you missed part 1, there is a link available on our website, so you can have a look on the recording. So today we are shifting from the theory part to the practice, and you can see there how to put these concepts from last week into real-world VHDL designs. So before we start with the webinar, I want to talk about a few general topics about our webinars and about the go-to panel. So go to the next slide. So our webinar will be about 1 hour, including a live Q&A at the end. And this will be a recorded session, so this means for you, we will send out a follow-up email afterwards to all attendees, and there will be a link to the recording. So, and this was a general part about our webinars. We will now have a look on the go-to panel itself. It may look a bit different on your screen, but here is really important, the question section and the handout section. First section is about your questions, also please submit your questions here. But as you may see on the first slide, we are using a new plugin. It's called Slido, and there will be a QR code. I will show you the code after this slide. We have enough time to access there. Really important is here, you don't have to log in. There's no account required for you. So you can just scan the code and you will access the question platform. And the difference between the go-to question section here and the Slido plugin is you can ask your question anonymously, and you can see all questions asked by the other attendees. And you can also vote for other questions if they are important for you as well. So, and then we have a better view at the live Q&A and highlight the most important ones. So here's one important fact. We try to answer all of your questions live, but if time runs short or your answers need your questions need a more detailed answers, we try to contact you afterwards via email. And then I have another section. This is the handout section. There you can see our training calendar. New today is we are having also our training calendar for next year. There you can see all of our dates and courses, from one-day courses to power workshops to our long-term education, and with direct links to our website where you can see detailed information about each course and the agenda. So please have a look on that. And then this was about the general part. Now I will show you the QR code where you can log in to the Q&A and ask your questions here. So as I show you the slide, I will happy to introduce you to today's presenter. He is my colleague Stefan Unrein. He is the head of the hardware development and also leads the FPGA team at PLC2. And he is here today because he is one of our experts and contributors of the PoC-Library, and also one of the creators of the Axi4Light register, which we will show today in our hands-on session. So welcome, Stefan, and I will now hand over to you.
Hi, yeah, thank you very much for the introduction, Anna. Yes, my name is Stefan Unrein. I'm head of hardware development at PLC2. And first of all, I'd like to show you a small introduction to PLC2, since maybe some of you don't know that. Besides the training and coaching that we are providing, since we are authorized training provider from MHD, We are offering also development service, since we are also embedded partner program from AMD and a premium partner there as well, starting with embedded software projects and finishing with FPGA high-speed projects. And finally, we have a third section where we have our own products. If you'd like to know more about that, please visit our website and check it out. Yes, so my name is Stefan Unrein. I'm head of hardware development at PLC2, and as Anna introduced me, I'm mainly focused on the PoC-Library, open source PoC-Library, and I'm the main contributor to the AXI4Light register. And welcome to my hands-on using the AXI4Light register in Vivado. So I'd like to directly go to the Vivado project and therefore switch off my camera again. So yeah, first I want to introduce you to the folder structure that we are using to our to almost all of our FPGA projects, which looks like this. First, we have the block design folder, or the BD folder, where we are storing our Vivado block designs. We have a folder where we are storing our documentation of this project. The Gen folder holds the files that are generated by the project, for example, bit streams, XSAs, and others. We have the IP folder, which holds the Vivado IP core and also other third-party IP cores. We have the library folder, which is most important in this talk, where we are storing libraries that we are adding as submodules, as Git submodules. We have the project folder where the XSAs, XPR files from Vivado are stored, where we have also stored the XPR file for this demo project. In the sim folder, we are storing simulation-related files like waveform configuration. In the source folder, we have the source files, VHDL source files that are necessary for this project. If the projects are bigger, we have also a subsystem folder where we are storing submodules, Git submodules for various subsystems like PCI Express, DDR, or others, if they're getting quite big, to separate it. In the TB folder, we are storing all our test bench files. The temp folder is for temporary files where we can write all the files into it that are not necessary after the project is built, basically. The tools folder holds all the scripts that we are using for that project. And finally, we have the XTC folder, which is the usual constraint file folder that we are using inside our projects. Yes, so this folder structure is used by almost all our FPGA projects as introduced. We have in this demo project inside the library folder, we have the PoC-Library added as a submodule. This is the latest release that you can find on GitHub. This demo project is also available on GitHub, so please check it out after this webinar under the PLC2 group. Yes, so the demo project, which is already open in the background, is based on a Xilinx UltraScale 3 EG chip, and is just chosen because it's a small chip and is also free to use on the free Vivado suite. And the first thing that I want to show you is how to add the PoC-Library into a completely new project. So as already mentioned, we have the library added as a Git submodule directly into our project structure. So first thing is we go then to add or create design sources. Here in this window, we add directories, and then we navigate to our project here into the PoC-Library. And under the source folder, we can find all the different sources. And what is most commonly used, which I will also add for this project, is the common, where we have all the common packages inside. We need the arithmetic functions, the bus functions, where we have also stored the AXI4 Lite packages and modules. We need the FIFO folder, memory, MISC, synchronizers, and in our case also Xilinx folder, where we have different Xilinx files. And if we add them here, we need also to change the library. So let me quickly do that. Make sure that you don't have copy source into project selected. Since we're using the submodule, we want to keep it clean and the files stored directly in the submodule from the PoC-Library. And add sources from subdirectory is added as well. So we need also two other files. So when we go into the project structure under source and common, we can find two templates. Please copy these two templates into your project directory under source and then PoC. And in these files, we have the local project settings in there. So you need to copy them over and update them with your settings. In our case, we are setting here the device chip with here the ZU4EG, and the other stuff you can leave as is. And for the My Project file, we have the project path. So in our case, with our folder structure, the synthesis path is 3 folders down. So to get to the project root, we are going 3 folders up. This will be important for later as well. You can also put here absolute path to your project. This is also fine. Okay, so these folders here need to be added as well to the project. So I will do that as well. I go up to source, PoC, and add both of these files. And then we click on finish. Vivado will take a moment to calculate all the dependencies or the compile order. So here you can see under VHDL, we have now 139 files. Not all of them are necessary for this project, but this is already a good start for having your project set up. So the next thing that we need to do is make these files VHDL 2008. So I will select all of them. Like this, right click on it, set file type, and then we select VHDL 2008. Some of you might know that the PoC-Library tries to be vendor independent. For that case, we have implementations for a couple of different vendors. In that case here, we have a couple of Altera files. So we can search for Altera and throw these files out. They are too much for us here. Finally, there is some other small thing that we need to do. When we are searching for ZIM, we can see we have a OCRAM TrueDo port simulation model in there. and this simulation model is not suitable for synthesis. So we go in here and deselect synthesis in the properties. That is only available for the simulation and nothing else. If this is done, we can then go to the hierarchy and see that all the files are available here. You can also disable some of the files if they are not necessary. But before we are jumping into the code itself, there is one thing that we need to add as well. The PoC-Library is coming with pre-made constraint files. So let's add them as well. We go into constraint files, add them inside the PoC-Library. We go into UCF folder. We need to have here FIFO. The FIFO independent clock GOT module has a XTC for it, and we need the XTCs for the synchronizers as well. So let's add them, click on finish. And now we have these files available here. If you open these XTCs files, you can see here a small description that we need to add them with scope to ref. This is because all the XTC files for the PoC-Library are done in as a relative timing constraint, which means it's this constraint is added to every instance of a certain module. To set that up, we go here into the source file properties, and if you scroll down, you can see here scope to ref. So we can copy the file name here and set all of them quickly up. So this was now the basic setup. Now the PoC-Library is completely set up for your project with all the timing constraints and everything. You can just use the PoC-Library with your project with all the modules that are available here. Now let's go to the demo project itself. We have created here a small block design. Let's quickly open it up. You can see it's a really simple block design. We have just a Sync Ultra scale with the low power domain AXI master port. Here we are having a protocol converter, which is converting the AXI for full bus to an AXI for light bus. And for our demo project here, we need in total 3 configuration ports, all of them AXI for light with 64 data bits and 40 address bits. That's basically it. We have also the PL ERQs coming into it, and the clock and reset coming from the PL, and the PL reset from the Sync is going into the VHDL files. If we check the address editor, we can see that all of the config ports are starting from address 8000 hex, and the second one is 8001 and then 8002. So a really simple block design that we are using here. We can close it up. I generate the output product in the background. So the next thing, if we want to use that, is we need to create a HDL wrapper. Since the out of context jobs are running right now, I will show you already the pre-made one. So as you might know, AXI4Light ports consist out of these standard logic and standard logic vector types with the address writes, address reads, data write, and data read ports. Since we want to simplify it with the PoC-Library, we are using our unconstrained record types for AXI4Light, and therefore have written a small wrapper for the block design, which you can see here. So that one is using the unconstrained record type inside the AXI4Light package inside the PoC with as a vector, which means we can have multiple configuration or multiple AXI4Light buses combined into one single signal. Since we need both directions, we have two of them available inside the port map, and all of them are basically connected to the VHDL wrapper from the block design. And as you can see here, all of them are going into this single port signal. So this one is just a little bit of abstraction to clean the project code up and get just a small port map like that. Now, if we go into our top level, we can see that we are getting the 100 megahertz clock directly here from the port map. We have also buttons, so push buttons coming from our demo board into the project, and LEDs that we are driving from our system here. So the next thing that we need to do from here is we need to create a generic packet. So from here, we have also inside the PoC-Library, not only the AXI4Light package where we have the unconstrained record, but we have also the generic packets for that you can create with this instance. So we are creating a new package with this name. We are putting always the sizes that we have into that name, which is in that case 40 address bits and 64 data bits. And this is the configuration that we have here. This is then used to create the signals for the configuration ports that we have just seen in the block design. And this is done by calling that newly created generic packet and calling the sized vector types out of it like that. The other signals that we can see here are just for connection purposes. We have a synchronizer, we have the resets and the clocks. And one thing that I want to mention here is that will be important for later. We have here also constant set up as a board revision that we are getting out of this package. So we have just a couple of board revisions defined that we are setting up here as a constant. Here we have a small reset synchronizer, the synchronizer for the push buttons, and here the block design that we have just seen, which connects to the design itself that we want to check out. So now let's go into the main design, which is the most interesting part for you. If we go in here, the first thing that we are always doing is creating a type where we can reference the different vector elements that we have out of this config vector, or of all the AXI4Light bus vectors. So I want to show you today a Git version register, a hardware configuration register, and a GPIO register. So we are taking this configuration vector from here, going into this Git version register. This is the instance that we are getting from the PoC-Library. So we are connecting here to the AXI4Light ports this configuration with the type coming from here that you can select the index 0 out of this vector. We are connecting also clock and reset. And inside the generic map, we need to set up a couple of things. We have the version file name. This is coming. This is where we are getting from on synthesis time all the different information from the Git structure beneath it. So we, as mentioned in the beginning, we have the temp directory for like these files that are pre-made just for this synthesis run. So we say we want to have it in temp git version mem. And now you might ask, where is this git version memory coming from? For that, we have also a pre-made tickle script that you need to add inside the settings. So you go under synthesis, pre-tickle, select here the file, and this one you can find on the PoC. And here you have the tools folder where all the scripts are located. Under Git, you will find the pre-synthesis Git version register Vivado tickle. If we select that and click on OK, you can see it here. And since we are already in the settings, please make sure to go down and set the assert box here, because PoC is using a lot of asserts to print out different configurations and also make sure that the configurations that you are making are correct. We want to have also printed out the register map under GEN version register, that we can verify how the register map itself looks like. I want in that case also to include the Xilinx DNA. That's why I set this generic to true. And I have a user ID field where I set the lowest 6 bits to this board revision that we have seen at the top level. And that's basically it. That's all what you need to do to the version register. And this version register will then be accessible through the address 8000 hex from the software side. Then the next thing that I want to show you is the hardware configuration register. This is basically just a read-only register that we are setting up in our projects to provide to the software different constants that the software might configure to. In our case, we are configuring here 2 registers that are read-only and have no register inside. So this means we are giving a constant from the outside. We have the names of these are config bits and config bits high. So we are setting it the register ports, which is a 2-dimensional vector, and then we need to write the different constants into it. In that case, I want to know how many PL IRQs are available, how many configuration AXI4 light ports are available, what is the size of my push buttons, and what is the size of my LEDs that are available. And all of them are 8 bits. And then basically, because of these settings, stored as a read-only value inside this address map under the address 8001 hex. Since I want also to have this configuration printed out, we can use an assert statement with write CSV file. We use the project directory that this constant is coming from the PoC-Library, and then we want to store it inside gen hw-config-rec.csv. That's it to that register. The final register that I want to show you is the GPIO block here, where we are controlling the push buttons and the LEDs. So for that, we are creating, again, a small register description. The push buttons are getting the current state with a read-only value here. I want to also to show if a button state has changed. For that, I'm setting up a register with a latch high bit clear on read. And I want to throw an interrupt for the software. That's why I set this register to be an interrupt register and set this port here to true. Finally, we have the LEDs register, which is in that case read-write, that we can change and modify the LED state. The setup here is almost the same as before. We are here creating the change detector for the push buttons and then writing the push buttons into the write port to the correct register names. And we are getting the LED states out from the read port, so from the read side from the AXI4Light register, and writing it into the LEDs. Here again, the same. We want to write the CSV file into a file. That's why we're calling here this function write CSV file and printing basically this register configuration into this file. Right. So this is all what I have to say about our small demo design. Let's quickly run it. And until the synthesis is running, let me quickly show you the tickle script that you have just seen. So as mentioned, it's located under lib, PoC, then tools and git. And if we open that one up, you can see that we have here a couple of tickle assignments where we are finally putting all the values that are necessary for the version register together, and we are getting all of these values from the shell beneath it with git calls that we have. This version file is then located under 3 folders up, temp git version memory. So this is matching what we have inside our folder structure. So if you have a different folder structure than we are using, make sure to copy this file into your local project and modify that path accordingly. Well, and when the synthesis starts, we can see at the very top of it that we get a call into this pre-synthesis tickle file, and that one is running the script and then writing that one into this temp directory. Since this is called at the beginning, it's already written even if the synthesis is not finished. So let's go quickly on temp, and here we can find the git version memory file, and the structure looks like that. It's maybe not really human readable, but the VHDL parser knows what each of these fields mean in the background. And now in the meantime, the synthesis is finished. So let's go quickly on to the Gen folder. Here we have now all the pre-generated CSV files. Later, we are planning on moving away from CSV files and putting it or writing it out into a YAML file, but this is right now still work in progress. So I will show you right now the CSV files. The version register looks like this. So here, all of the registers are written into this CSV file. We have the configuration index, we have the name of the register, the offset address of this register, and the other settings as well. Here you can see all the different registers which are available inside the AXI4Light register. And yeah, this is the structure that's how it looks like. If we go into hardware configuration, it looks a little bit simpler since we have only configured 2 registers, which you have seen. One is config bits and one is config bits high with the address 0 and address 4. And here we have also the register modes as read-only, non-registered. Finally, we have the GPIO register with our 3 entries that we have specified. And here you can see that the bus edge register is the latch high bit clear on read, and that the interrupt that this register is set as an interrupt register. So now we have seen all of the structure that we have underneath. That synthesis is already finished. So let's quickly open it up. Let's quickly have a look on the schematic itself. We can see here the configuration with the through independent ports, which are connected from the block design into our project. And as you can see here, we have 3 separate registers available here. And what you might notice is, if we have a look into it, that all the write ports and so on are terminated to 0, since the version register is a completely read-only register. Only the read side is connected, and everything else is optimized away. The same is true for the hardware configuration register, and for the GPIO register, we can see that here the write port is available as well. We can also check the utilization here. So if we go and open the utilization report, we can see that the Git version register takes up 295 lookup tables and 183 registers. So these lookup tables are mainly the read-only memories that have all the necessary Git information available here. If we open up the version register as well, we can see that there is another small instance, which is calling the Xilinx DNA port that we have enabled through the generics. With that, we have available inside the version register also the Xilinx DNA, which is the unique chip ID of the Xilinx FPGA underneath it. This is what I want to show you as well. How does it look like if we have these informations available? For that, I'm switching to PuTTY and going onto one of our ADLs, which is our data logger project or data logger product at PLC2. And here we are at the console, and for that we have a command ADL -version, and with -p we can get the version of the PL underneath it, and it looks like that. That is all the information that we are getting from this version register that you can see in the background. We can see the build date when this bitstream was built. We can see the register version, which might maybe change in the future. We can see the Vivado version where this bitstream was built on. The project name, so what's the name of the XPR that we had, the project version, which is the Git tag that was used. And what we can see here as well is that this is a development bitstream, which is 23 commits ahead of this tag 1.0.0. We can see the Git hash, the Git date, and the time as well. We can see that it was built on a detached head, which is the case if you are running in a CI environment. We can see the URL as well. And finally, we can also see here the unique chip ID, which is provided here from this Xilinx DNA port. This user ID field we have also set in this demo project, but this was not the case in our ADL design. That's why this is set to 0. And it might be also possible to set the eFuse bits and read them out here as well. So that's all that I have to show you about the demo project itself and how to use the Axie for Light registers in 3 different variants, from the Axie for Light version register to the configuration register and to a GPIO register. And finally, as a last step, I want to show you where you can find the documentation. For that, you can go to VHDL github.io/PoC. There you will land on this site here, which is the official documentation from the PoC-Library. And here you can see in the news directly highlighted that we have the Axie for Light register here. If you click on it, you can see the documentation with all the generics described, what is the purpose of it, how to set it up, how to configure it. The ports described here as well, and the configuration. As you can see here, it's still work in progress. We are still working on porting it from Markdown to the GitHub pages. So that's why the documentation is not fully finished yet. But you can see here already instantiation templates, how to use it, and yeah, other resources as well. The same is true for the Git version register. This is also available here on the GitHub pages. But as you can see, it's still not finished yet. What I want also to show you is the last release that we have for the PoC-Library on the group VHDL PoC. Here you can see the new features that we have introduced, which is the version register and other bug fixes and changes as well. And visit, you can visit or check out the code from the PoC-Library directly here under VHDL PoC and download it and hopefully use it also for your projects as well. So that's it from my side. I hope you learned a couple of things. I hope you will use the PoC-Library in the future in your projects. And yeah, thank you very much for your attention.
Thank you, Stefan, for your presentation. Can you show us the slide again, please?
Sure.
So really important for you is now, if you have any remaining questions, please share it on Slido so we can talk about that directly. So here are some questions coming in. I will maybe you show the other side. Before we start with the Q&A, I want to talk about a few other topics. So now I'm on the right side. Sorry for that. So if you're not joining the Slido platform, here's the QR code for you. So please remember here, there are no account required. You can just scan the code or go to slido.com and put in the hash code. So then really important for us is on the webinar series from the PoC-Library, there will be a 3-part. This is next Tuesday coming. It's about the CDC components and the synchronization primitives. We are talking about that on the 3rd part next week. So please register for that for free using the second QR code here in black. And then I will talk about the FPGA conference. You may already be familiar with that. So please save the date for next year. It's coming in June, end of June. It's a 3-day conference filled with a lot of speeches about different topics, keynotes, an extra exhibition hall, and a special evening event. So if you want to read more about that, please use this code. And then we have the 4th code on the left. This is about our LinkedIn account. If you want to stay up to date from PLC2 in general, please connect with us on LinkedIn. And for now, we are going to the other slide. I will go back here, where you can see the answers. Yeah. So I will. I hope you can all see the questions. The first one is it possible to use PoC files in course package with IP packager, because that usually throws critical warnings when you use VHDL 2008 files?
Yes, thanks for the question. Yes, this is possible, and it's true that Vivado is throwing critical warnings, but these warnings can be safely ignored. We have used it in other projects as well, and even if you are using no unconstrained records, also just using the files as VHDL 2008, you can see immediately that it's throwing these errors as well, or not errors, but critical warnings. So there is really no downside besides that this is just an unnecessary critical warning, which is Vivado throwing out. This is coming since Vivado has the support from VHDL 2008 since a lot of years ago. And since then, Vivado has improved a lot with the compatibility with VHDL 2008, but still they are throwing it this critical warning. So in my opinion, you can safely ignore this critical warning and use the files there. The only thing that you need to know when using the PoC-Library inside the IP packager is you can only use the my project file with the path which we need to set up there in a relative way. Since we are using the IP cores in different locations and Vivado is copying them together as necessary, you can't use absolute path, but besides that, there should be no problem at all.
Okay, that brings us to the second question. Is there a Tcl script for setting up a new project or one for adding PoC to an existing project?
Yeah, that's a really nice question, because this is exactly what we are working right now on. This is right now not available yet, but we hope we can introduce that Tcl scripting that you are referring to in the next major PoC release. So hopefully in the version 3.0 that we will provide in the next time, we will have that scripting available like that, with a Tcl infrastructure where you can just say add PoC-Library or add this and that IP core from the PoC-Library, and all the necessary files will be set up automatically for you. Right now, this is not available, but we are working on it.
Okay, I don't see any more questions here coming in, but please remember, I will. Oh, okay, there is a question coming in over the go-to panel. Would you be able to summarize the main step in integrating the PoC-Library in a Vivado project?
Well, the main step, you can also later see my introduction on the replay when this webinar is finished. But the main steps are basically adding the files from the submodule, the files that are necessary for you, for sure. Then you need to filter out the Altera files if you are running on Vivado or on other platforms when it's not matching for you. Setting the files to VHDL 2008, since we're using unconstrained records for the connection, especially for the bus infrastructure. And if you're using the synchronizers, then you need to set up the constraints and set the scope to ref there. This structure or these main steps are, I think, not right now described in the documentation. So I hope that we can add that in the next couple of days for you as well, that it will be simpler to use for you.
Okay, I think for you as important info. I will keep the broadcast on for the next 5 minutes. So if you have any last minute questions or so, please stay in and you can ask them the next 5 minutes too. But for now, I think this is the end of the webinar. So thank you all. Oh, there is a third question coming. So I will read that for you. Scope to ref means that all components of that name or type will use that constraint.
Right. So scope to ref means basically you use relative timing constraints. As you can see inside the constraints from the PoC, they're basically taking the instance that you are putting into scope to ref is for that constraint file basically the top level. You can think about it like that. So all the constraints are relative to that, and this constraint file will then be used for every single instance of that component. And this makes it really easy to use the CDC functions or the FIFOs and so on, that every single instance has the correct timing constraints underneath it, only any kind of user interaction. But this scope to ref will be introduced, or not introduced, but described in much more detail next week in the webinar, since the main focus there will be timing constraints and the synchronizers that are inside the PoC-Library. So if this is interesting for you, yeah, join the next webinar on next week.
Yeah, okay. So a little reminder for you, I will talk a little bit more, maybe there coming another question in. The recording will be available for you afterwards in the follow-up email, so you have a look on that in your own pace again. If you want to look a bit closer in single sections of the webinar, and yes, if you have questions afterwards, you can contact us and we will try to answer it via email. And let us know what you think of the webinar. We have a quick survey coming up when the broadcast ends, so please don't close your browser window, as your feedback is really incredible, valuable for us. So please take part of the survey. And so I think this is it for the webinar, the PoC-Library hands-on using AXI for Light with Chester and Vivado. And I hope you will come back next week for the third part. And thank you all for joining and have a good day.
Yes, thank you very much.
Bye all.
Goodbye.